Welcome to ConceptGuru.
where learning is fun. Today's chapter is HCF. HCF stands for highest common factor. Now this is a topic that is mostly taught in about grade 4 or grade 5. And a related concept is LCM, which is lowest common multiple. Let's get started. So the prerequisites ones for this topic would be what are factors, what are the prime factors, and how to prime factorize a number. We have a video on our channel by the name of Factorization, and you can go through it for a quick recap. Let's also do a quick recap on how to do factorization. Let's try to factor this number 12, finding out its factors by the prime factorization method. So here we see 2 into 2 into 3 makes 12. So the prime factors are 2, 2 and 3. Now 2 into 2 here is 4. 4 becomes a factor but not a prime factor. And similarly 2 into 3 is 6. It is also a factor but it is not a prime factor. So with this quick recap, let's go on to introduce highest common factor or HCF. Now this is not for one number. So when we are trying to find the HCF, it is not for one number, it is for two or more numbers. So your question would be like, find HCF of 6 and 9 or HCF of more than two numbers 6, 9 and 12. These are two examples. Highest common factor, found by the words highest, common and factor. Why highest? Because it will be just one single number. So you'll be given 6, 9 and 12. To find out HCF, there will be just one single number as the answer. Why common? Because it would be common for all the numbers given. And why the word factor is, it has to be a factor, but it may or may not be a prime factor. Like we saw, 4 and 6 are factors of 12, but they are not prime factors. So your HCF need not be a prime factor. We are going to show the factorization method here, finding the HCF of 6 and 9. We start with very small numbers here just to understand what is the concept first. Now the first step will be to factorize these numbers individually. So you factorize 6 and then you factorize 9 like this. Okay? And then what are the factors? The step 2 is what are the factors that are common but also which is the highest. So 6 is 2 into 3, 9 is 3 into 3. 3 here is the common factor in both these operations, and 3 also happens to be the highest. So we can safely say that 3 is the HCF of 6 and 9. Let's move on to another example where we have three numbers here, 12, 24 and 30. And our question is to find out the HCF of these three numbers. Again, let's follow the steps one by one. So the first step is to factorize the numbers individually. We go on to factorize 12, then 24 and then 30. Now what is our step 2? We find the factors that are in common and a combination of those factors which form the highest number. So here is 12, here is 24, here is 30. Now trying to find the common factors here. 2 happens to be the first common factor in all these numbers. Then we find that 3 is also a common factor for all these numbers. The combination of 2 into 3 or 6 will be the HCF of 12, 24 and 30. Shall we try finding out the HCF of 20 and 21 now? We follow our steps, individually factorizing 20 and 21. And now there are no common prime factors, right? So how do we calculate HCF? So ideally we would say 1 has to be the HCF of 2021. But that is meaningless, as 1 is a factor of every number, right? So there is no HCF for 20 and 21. Let's go on to some HCF applications here. Now these are the kind of problem sums that you might encounter. What is the biggest number that can divide 8, 12 and 16 without having any remainder in every case? So you have to find that biggest number, but it has to be also common. So highest and common, and then when you are dividing 3 numbers with a number and it is leaving no remainder, it has to be a factor, remember? So one single number, it has to be the biggest one and it has to be common. And the solution has to be 4 in this case. You can work it out. Let's do another regarding a practical application. What is the biggest length of ribbon you can cut out from ribbon reels of 6 meter, 9 meter and 12 meter, so that all such pieces are equal in size? So let's say this is a 6 meter ribbon, this is a 9 meter ribbon and this is a 12 meter ribbon, and you have to cut this in such a way that you get common length of all the pieces and that are equal. So here in this case the HCF is 3 meter. 3 is the HCF of 6, 9 and 12. Now tips for parents. Factors are smaller and multiples are bigger numbers. This concept should be clear with the child. Example 7 is a factor of 14 and 21. 14 and 21 are multiples of 7. Among 3 numbers like 9, 18 and 27, 9 will be an obvious HCF as 18 and 27 are multiples of 9. Practical applications like cutting ribbons into maximum length or dividing into teams of maximum size can be explained to the child. Now our upcoming video would be on LCM, where after explaining that concept, we are also going to differentiate what is HCF and LCM with the help of problem applications.
Thanks for watching. Please like, comment and subscribe.
Press the bell icon for our latest videos.